Okay, now we're starting the recording. So yes, happy Garbage Day, Roomers, Zoomers, folks listening from the beyond. I have our class syllabus up here just to make some announcements regarding schedule. So next thing that you would be working on is finishing your Homework 1 accuracy draft. There is a separate entry for that in Icon to turn that in. And that is the one that I will read carefully and provide feedback on. You get another 5 points basically for revising your answers based on our discussions in class. If there's anything with that you're not sure what to write down, please let me know. And if you have lingering questions that you want to include as part of your answers, I can answer those at the same time. So that's fine too. After that, we have another formative assessment, and then we have something called Project Outline, which is due the week before spring break. That does not exist yet. I will make it exist and post it later this week. But what I'm looking for is for you to figure out if you're going to work with a partner or not, and let me know who that is if you're choosing to. I will also ask you about scheduling conflicts for doing presentations. So I've got 3 weeks set aside for those, but I know one of those weeks is AERA and NCME. So if you're going to be gone, I will ask you questions about your availability. What data set you plan to use and a brief description of it, and then maybe some questions about, like, broadly speaking, what kind of analysis are you planning? Like, what are your predictors? What are your outcomes? That way I can weigh in on aspects of your plan. So that is for us to begin a dialogue about what you're planning to do for your, I'm not calling it final project, we're calling it April project, because that's when it's happening. And as a reminder, there will not be a paper, but there will be a presentation. And one of the parts of your grade will be also providing feedback for other people's presentations. So like with everything else, though, this is still a mastery format. So if your presentation does not go well, you can redo it and film it and send it to me to watch as a revision. And that is due at the end of finals week. So I do want this to hopefully be the launching process for something else that would be useful to you, such as a conference presentation. For those of you who are in the EMS ProSim and you need to present something, maybe you could present this and kill 2 birds with 1 stone. So I'm pretty flexible on what you might want to do. Ideally, it would be material that we have covered. But if it's something that stretches beyond that you feel capable of because of your other experiences or coursework, I will allow that too. So just to give a heads up that is forthcoming. And I did update grades this morning for homework 2. Not everybody has finished it yet, so I can't answer class questions in front of everyone, but if you have specific questions, I'm happy to answer those. If you want to make an argument as to why you think your answer is correct, I will listen to those as well. And sometimes I do change my mind or just give folks the points if there's something that was unintentionally vague or confusing about it. I try to be reasonable about that. Let's see, what else is going on? So I said Happy Garbage Day. I'm not going to say Happy Valentine's Day, though. I'm not. On behalf of all food workers, waitresses and waiters, hostesses, bus boys and girls, if you're planning on going out to eat tonight, just don't, okay? Just stay in your houses and your apartments. Eat the food that is there. Trust me, you will have a better night. Everyone goes out to dinner on Valentine's Day at the same time, and it is horrible for everyone involved, so just don't. Celebrate in your houses. Have a random dinner next week when no one is going to be in the restaurant, and you'll get good service, and it will be quiet and calm and nice. So that's my advice to everyone here about that. Let's see. Oh, Thursday, we have forecasted snow again. So just as a heads up, if Iowa City schools are closed, we're not having class. I will let you know for sure that morning. I am going to bring the good laptop home with me, though. That way we don't run into issues with bandwidth and lagging. I figured out in the next class, after this one, that it's not Zoom, it's actually the recording software that crashes my computer. So I have it configured apparently to a level where it takes over all of the processor. And rather than try to fix it, I'm just going to take the good computer home that I know works. So we should be good to go on that. But just as a heads up on Thursday. So any questions or things I'm forgetting to talk about or mention with respect to schedule stuff, upcoming due dates? We're good to go. Zoomers, anything on that end? I'm assuming you can all hear me and see me since no one has complained yet. And I remembered to share the screen. No. All right, then I'll shut this off and we'll head back into lecture 3. Thank you, wavy thumbs. I have to be careful when I do my hand gestures because Zoom recognizes it as me raising my own hand in class. So I'm like, no, that's happened several times where I look down at my picture and my hand is raised. And I'm like, I don't have a question for myself. Like, well, I do ask rhetorical questions, but I didn't intend to raise my own hand. But that's a feature, apparently. So we have lecture 3 here, transitioning into the wonderful world of structural equation models as a way to estimate longitudinal models, and then showing how the age cohort example that we did using MLM software can be estimated using 2 different approaches within the SEM world, multi-level and then regular flavor single level. So this was where I think we got to, as memory recalls last week, slide 4. So let me see what you remember from last time. What's the big difference between what is possible basically in the software that you know, which I'm calling univariate multi-level for estimating longitudinal models, and what do you get out of moving to an SEM framework?
You can estimate multivariate.
Truly multivariate, that's the big thing. The big difference that allows all of the additional capabilities is the idea that you can predict more than one column in a data set simultaneously. In Elmer and in Mixed and all of those packages, there is one Y, and that's all you can have, which means that all of your predictors are not in the likelihood. That means they can't have any missing data. It means that you can't have one predictor you can't have one outcome predict another outcome. It means that your random effects themselves cannot be predictors. So for example, if I have a study of reading development in elementary school students and I want to see how initial growth rates in reading predict high school outcomes, that's a fairly common type of research question. I can't do that in Elmer, because the growth trajectory, the random intercepts and slopes that you'd estimate in Elmer are always outcomes. They are never predictors of something else. So you'd have to logically turn your model around to answer that question and make high school whatever a time invariant predictor of what happened in elementary school. Now that's not wrong, but it's kind of weird. And it doesn't really allow you to answer the question about whether your random effects would have unique contributions above and beyond other variables in that setup. Another thing, growth of factors. So if you wanted to represent your outcome as some kind of latent construct with its own measurement model, can't do that in Elmer either. So there's a lot of additional modeling features that moving to an SEM framework buys you. And I wanted to show you how to move into both of those, as well as some examples of extra cool stuff that we can do because we can move into both of those. So that's kind of the rest of the semester, is sort of heading in this estimation direction. Okay. Let's see, I think that's the first 4 slides or so. Yeah? That sounds about right? Okay. Questions so far? So then software packages. So when people say SEM, they are saying single level SEM. It is possible to fit multi-level models using single level SEM. It is also possible to fit multi-level models using multi-level SEM. The difference between the two is the data structure. Multi-level SEM uses a long data structure where each row is a level 1 observation. So occasions within persons, for instance, times within days within persons, all that stuff. Single level SEM is a 1 row per person data structure where all of your specific occasions would go in separate columns. There are many more possibilities for doing models in regular single level SEM in terms of software than there are in the multi-level version. So for instance, R-Levon is an SEM package that is well loved by many people. The multi-level version of it is very limited in what it can do. OpenMX is another package that interfaces with R. I think it's a standalone program, but it has like an R pass-through the way that Stan does. That has more options. I have not tried to use it. Everything in it has to be specified as a matrix, which is one of the reasons why I haven't tried to use it, because I don't think in matrices very well. BRMS is another package I've heard good things about. I have not had a chance to play with it very much, but you played with it the other day, Vladimir. Works fairly intuitive.
Yes.
So I don't know what all it does, but I know that that is mentioned in this vein of things. Stata has both SEM and GSEM. GSEM stands for generalized, but it also has a multi-level component to it. It looks to have a lot of capabilities, but I haven't had much experience with it yet. M+ is what I'm going to teach you because it is constantly being updated. It's intuitive. You can use Bayesian estimation or maximum likelihood, and they have extra features that aren't in these other packages, which are labeled as dynamic SEM, which involves time series kinds of parameters like autoregressive and lagged effects and stuff like that. So I'm going to do SEM. One note about unbalanced time, you need something called a definition variable if you're going to use regular structural equation modeling software with unbalanced time. And I'll show you more about what that means, but the only place that I know to get that is in M+. There's an option called T-scores. It's not in Lavaan, and I haven't found it in the other packages yet. So that's the one big feature that if you have balanced time, you can do anything. If you have unbalanced time, it's a lot more restricted. Okay, picking up on slide 5 then. Question, are location scale models multi-level SEMs? Location scale models, not a coincidence, right, that you're asking that question, Allison. She has a grant in which we propose to do those. Location scale models are when you are taking a standard univariate multi-level model and you are allowing heterogeneity of variance as a function of predictor variables. So the idea of, for instance, level 1 residual variance is within person variation. Some people are going to have more variation than others across time. You can allow level 2 predictors of that. Those models can be estimated in some univariate packages so long as all of the variances you're interested in are outcome variances. But if you wanted to have, say, variability across time as a random effect that predicts something else, then you would need to be in the SEM world because you're having a random effect as a predictor and not an outcome. M+ has location scale models as well. So that's a feature that we'll probably get to later in the semester. It's a newer feature in it. There's a bunch of dedicated packages that folks have written, but none is as flexible in terms of bringing everything together. Okay. Other questions? Am I talking too fast? I feel like I'm a little manic today. I don't know why. I only had 1 cup of coffee this morning too, so I'm actually below like my usual level. Okay. So what I wanted to do is do the multi-level SEM side first, because I feel like that's less of a leap relative to where we are. Show you what the syntax and output would look like for the same models that we did in example 2 with age and cohort. And then make the transition into single level SEM, which is a little bit different in how it's set up and what that software syntax and output would look like. So multi-level SEM is where we are first. And there are sections of the syntax that are labeled within and between, where within stands for level 1, between stands for level 2. And those labels are always applicable, no matter what kind of multi-level sampling design you have. This fall, if you come back to do the clustered multi-level class, it will be within and between clusters. Right now, it's within and between people. For Carl, it's within and between companies, right? Within and between schools, like within and between something always works. You can do 3-level models in M+, by the way. There's 2 levels of between in that case with an ID variable to keep track of which is which. The way the output is labeled, though, is potentially confusing because of a convention that M+ uses for all of its models, where they differentiate parameters that are for variables that are predicted from parameters that are for variables that are unpredicted. So unpredicted, if it's a variable that's been brought into the likelihood. So I would call that a predictor except that in this context, it is a predictor that someone has turned into an outcome so that they can have missing data. But it's still, in terms of your model, not being predicted by anything. Then you will get a mean for it and you will get a variance for it. And there's a separate section of the output that's labeled that way. If you have a variable that is predicted, meaning it's an outcome, and it's in the likelihood because it's an outcome, then you don't have a mean for it, you have an intercept. You don't have a variance, you have a residual variance. The difference is the conditionality. So a mean is unconditional. It's the expected outcome for anybody, regardless of whatever. An intercept is the expected outcome of that variable, specifically when all the predictors are 0. Likewise, variance is all the variance that it has, residual variance is left over. Now, why I make this point is that I have been very specific in saying that residual variance is level 1 and random effect variances are level 2. On your output, you're going to have within residual variance and between residual variance. Between residual variance means leftover random effect variances. And we'll see that.
One more time, sorry.
Yep. So the way that I talk about these things, to avoid confusion, I always say level 1 residual variance. That's the E's. Versus level 2 random intercept and slope variances of the U's. And I always say that way. But in your output, M+ will give you within level, meaning level 1, residual variance, but then you'll also have residual variance show up again in the between level. That term, when it's in the between level, is referring to your random effect variances. Related to that, some multi-level textbooks use the term level 1 residual and level 2 residual because they're meaning U variance left over at level 2, so it's residual in that sense. And I find that really confusing. So, another part that's confusing in this syntax is where the slopes show up. If you have a slope of a level 1 time-varying predictor, such as time, it could show up in the between output or it could show up in the within output, depending on how you write it. So I will show you this as an example, and I'll show you why it has to be this way. Level 2 slopes for level 2 time invariant predictors are always going to be in between. When we add random slopes, this is where it gets even trickier, because when they introduced their change in estimation, you can run the exact same model syntax and say estimator equals ML or estimator equals Bayes and get 2 different versions of the level 2 model because of the way they program the Bayesian algorithm. And that made me so frustrated that I wrote a whole paper about it. So that was the genesis of that. So I will, this will be like an ongoing conversation that we have. I just want to sort of prepare you for some of the difficulties, because there's a more ambiguity in what's actually happening than in a traditional sort of univariate, this is what Elmer's doing. Okay, so here's a model for you. I'm changing up my color scheme a little bit. Red things are still fixed effects and blue things are still terms in the model for the variance, either a random effect or a residual. But to help us like map the equations onto the diagrams, I'm making new colors. So purple is the blending of blue and red, because red and blue together make purple. They do, right? And that's why my SEM class has purple, by the way, for its background, is because everything is sort of blended together in that class in a way that doesn't happen in the other classes. And that's why we have purple headers on the slides, or the homework system in the webpage for this. So this is what I would call, this is a random linear time model. And I'm calling it unconditional because at level 2, there's no other predictors, and there's nothing at level 1 besides time. So this is well-covered territory. This is not a new model. So the level 1 model then has our individual intercepts, an individual time slope. It would be linear in this case, doesn't have to be. And then each of my intercept and linear slope has a random effect that goes with it, and the fixed effect is what happens on average. E is what's left over. If I substitute in for the beta placeholders, I get this composite equation where the term in parentheses is beta 0, the term in parentheses here is beta 1. Okay, cool with that? Time is a predictor. So y is a column in your data set, time is a column in your data set. Here's a picture. The multi-level SEM, whenever it's shown in equations, it's almost always shown in matrix equations that I find completely unhelpful because the contents of the matrices you have to know in order to know what the model contains. You will see diagrams like this in the M+ manual, also in the STATA manual, as a new type of diagramming convention. So this is a multi-level SEM diagram. We have the middle row of boxes as the original variables in the data set, and then we have the level 1 model is circles underneath, the level 2 model is circles on top. Now, a couple features about this. There is only one box labeled level 1 Y because this is long data. It is one column for a box. The same conventions that are typically used in path diagrams and in SEM are used. Boxes are for things that are real. Circles are for things that are pretend. Excuse me, latent. They're latent, not pretend. So level 1 time, likewise, is a predictor in your model. So that's the orange variable in the equation here matching the orange in the box. So level 1y then is being partitioned into two sources of variation, otherwise known as two latent variables. So we have level 1 at the bottom here. I have a circle for ETI. This is the variance across time that remains after controlling for this effective time over here. It has a mean of 0 because E's always have a mean of 0. It has an estimated variance of this residual variance right here. E, when it's added into the model here, there's no constant in front of E, so that's why I have a 1 here on the line that goes to it. That would be like if there were to be a factor loading somehow, that's where that would go, but it's just a 1. So the fact that we just directly add E here is why this path to it is 1. Then the other half of it, the level 2 intercept, the overall circle here is labeled beta 0. So the circle is beta 0 as a variable. That variable has a mean and a variance. The factor mean is your fixed intercept. The factor's variance is your random intercept variance. And I'm calling it mean and variance here, M and V, because it's unpredicted. So everyone has the same expected average of given by just gamma 0, 0. And the variance term is all the variance in the intercept that there is to be had. This U enters in here, or excuse me, this beta enters in here directly without anything in front of it. That's why there's a 1 right here. Okay, with me so far? Now this thingy over here, time is a box. If this were a standard path diagram, there would be some sort of coefficient labeling how x as time predicts y. In this diagram convention, we labeled the path with the placeholder for that slope. The slope itself has a fixed part and a random part. So it's like this little black circle is meant as a placeholder for this entire latent variable being stuck onto this directed path right here. So it's an abbreviation system. Question, what is the meaning of the dashed arrow? The dashed arrows are all paths that are fixed to 1, whereas this is a solid arrow, meaning that its parameters are being estimated. That is not a standard thing. That's something that I do when I make these pictures. I try to use different types of lines to convey different kinds of paths. So if the effective time were fixed only, then I would just stick gamma 1O on this path as a label. But because the effective time is random, there's a bubble here as a placeholder for how that random effect is created from a combination of the fixed and the random together gives me beta 1. So in terms of variables that are being partitioned by the model into levels of variance, there's only one. Y is having its variance partitioned into intercept at level 2 and residual at level 1. X is not having its variance partitioned at all. The slope of x to y is this circle right here. Paths are slopes. Arrows are slopes. Two-headed arrows, like the one on top here, are covariances. So I have a two-headed arrow connecting the intercept and the time slope to indicate that we do estimate a covariance between them. That is not a default in the package when you do an MSEM. It is a default in the package when you do a SEM. I didn't make the rules. But this is why when I write code, I write everything, so that you don't have to know what the defaults are. Yeah.
So in this case, we are fixing those factor loadings to 1 to estimate the variance, right?
Yeah, there's no factor loadings in the story yet.
Okay.
Everything, all of these paths are all fixed to 1. They directly predict, or they're directly added into the composite linear model.
And we are also estimating those factor means, right?
Yes.
They are being estimated.
The factor means are being estimated because those are the fixed effects.
Okay. But we don't need a market item or something?
No.
Okay.
No, we do not, because there is no like separate intercept for this variable.
Okay.
It's up here.
So model identification is not a problem yet?
No, I got one column of Y's here. Now your questions are going to become relevant when we get to the single level SEM side. But I think understanding the switch from us, like we're continually differentiating fixed and random effects, and we don't really pay attention to the betas. In this estimation context, everything is phrased as the betas. Like it has a fixed part and a random part, and that like beta is the term though that would be a predictor or an outcome of something else. What's next? Okay. Here's the code that goes with this picture. So this is for a generic example. I'll give you a more specific example later. So the model section of M+, after you tell it what your data set is, what your variables are called, what estimator you want, all that stuff, then it's % within % is level 1, and then % between % is level 2. No semicolons at the end of these lines, though, but every other line has a semicolon at the end of it. Comments in M+ are an exclamation point, which is why they're green. So my notes out to the right here, those are all comments trying to help you. You don't have to type them if you don't want to. And I write everything out. So my code will be longer than what you will see in their examples because I don't want to make you infer anything about this model. So in M+ parlance, when you list a variable by itself, you are referring to its variance. Based on the context of the model, it is either residual variance or just unresidual variance, like just straight variance. It knows which is which. There is no difference in the code. I know that this is residual because y is being predicted by time. Next line. Y on time is how you specify a directed slope relationship where it's y on x. So this is time predicting y. This is my level 1 model. I'm setting up this idea of beta 1 here. The name Lin is beta 1. Lin is a placeholder for what beta 1 is going to become. I could have named it beta 1, and I have that in the comment here, but I prefer to name things in a more direct way if I can. This bar thing here is like a definer. Like what I'm doing is taking the regression y on time and I'm giving it a name, and that name is Lin. in the same way that this slope right here has been given a name of beta 1. So the model, the multi-level model representation directly corresponds to the syntax. In the between model then, things that are in brackets for a variable are either its intercept or its mean, based on whether it's being predicted. So y, that's how I get the fixed intercept for y in the bracket. Likewise, ln, that's how I get the fixed slope for the linear effective time. It is the mean of the slope variable I defined up in the within model called ln. Listing the same two variables outside the brackets refers to their variances. So y is random intercept variance. There is no way to relabel it, by the way. So whenever you see the name of your outcome variable, it's intercept. Ln is a random slope variance. And then y with ln is the covariance between those two random effects. With means covariance. So there's only really 3 different keywords in M+ for relationships. There's on, which is a regression, with, which is a covariance, and by, which is a factor loading. That's it. There's a whole bunch of special characters, as you can see. They used every single special character on the top of the keyboard. They have. The last version of M+ used the only one that was left, which was a caret. Okay. So this code will give me the exact same everything as if I put this in Elmer or SAS or whatever, so long as I keep the estimator the same. SEM, either the multi-level or the regular version, does not have RUML. It is not a thing. No package does. So if you ever get different answers between like an Elmer fit and a multi-level fit, check your estimator. Otherwise, you put something extra or a constraint where the models aren't the same. But otherwise, these are both maximum likelihood. You should get exactly the same answers. Question?
And you mean same answers in terms of their model fit or like the actual parameters?
Everything. Log likelihood, parameter estimate, standard errors. So the p-values, though, are going to depend on what kind of degrees of freedom you're using. So I opt for Satterthwaite in most of the examples that I have because that is common across all the multi-level programs I would teach in. But degrees of freedom are not a thing in SEM either. So what you get are z-tests, Wald tests. So if your p-values are different, that's why. It's a combination of estimator and degrees of freedom. And I have seen simulation research, by the way, comparing these sorts of models as if they are different alternatives and reporting differences and attributing it to being MLM versus SEM. That is incorrect. It is estimator and degrees of freedom. Sorry, I didn't mean to sound like I'm yelling at you guys. That sort of thing makes me really frustrated when I see like that get through the literature and get published. It's like, come on, dude, this is an amateur level mistake. But I know you would never do that, so no need to yell. Okay. Okay so far?
Yes, but
Question?
in the case of missing data for the predictors here, they would be included?
Not yet.
Okay.
Yep, so any row of my data set that is incomplete with respect to y or time is not going to be included. Same story. I would have to bring time into the likelihood as an outcome, and I have not done that.
And we're using full information, maximum likelihood?
Yes.
Okay.
Yes. So when you're predicting conditionally normal outcomes, full information is what every program does.
Sure.
If you fed in a covariance matrix and asked to estimate the model using that, that would be limited information because you don't have the original data. In predicting categorical outcomes is where the distinction matters, whether it's full information or limited. Missing data would be the only reasons, given a conditionally normal outcome, that you'd get a different answer from full information versus limited. Yep. Okay. All right, here's a more fancy model. Unconditional random quadratic. So I've added a circle over here on the left-hand side. Do I have code for it? Yes, I do. Okay, good. So still unconditional because it's not being predicted by anything at level 2. Note that I have a third box here in the middle layer of my picture, which I've labeled time squared. And in M+, you need to make that yourself. You can't just say time by time somewhere in the code and have it figure out what you mean. You have to make the box. There is an option in the syntax, though, to make new variables, to do centering and squaring and that kind of thing. So this is random quadratic, which means that I've added a third circle here for beta 2, whose mean is going to be the fixed quadratic slope gamma 2O, and whose variance is the variance of the U. Uh-oh. Spot the typo in Lisa's slide. The second U1. That should be a 2 here. Yeah, make a 2 for this, please. I'll fix it after class. So the variance of the U2s goes right here. So we have the same system of notation where beta 2 is the label for the path from time squared to y that contains the fixed effect as the mean and the random effect variance around it. This convention, by the way, is something that I do and I've seen other folks do. The arrow at the top that's just a straight line with the little arrows going from it is meant to convey all possible covariances between these three things. That way you don't have to draw them all. It's a little cleaner. But then you can't label it as easy. So this would be like a note for this diagram that says these mean all possible covariances. Here's the code that goes with this picture. So now in the within model, it's the same, except I added a second placeholder, which I called qua for quadratic. I tend to name things so that all the terms have the same length. That way my code stays easy to read. That's why I didn't say quad. But you can have up to 8 characters for each of these terms that you're creating. And that qua is the name of the regression of time squared predicting y. So then qua gets added to the mix here as a fixed effect in the brackets. So that's my fixed quadratic time slope. The random variance around it across persons is qua when it's just outside the brackets. And then adding it to the width line, when you list 3 things with and then the same 3 things, that's all possible covariances as well. You don't have to write out 3 separate with statements. You can do it this way. So in the comments, I'm also adding, like I have G in parentheses here to try and connect that to that's what we would call it. Like these are random effect variances and covariances. This is my G matrix. My R matrix is right here, level 1. And unlike what we have available to us in mixed software, there are no separate variances per occasion thing built into this. It's treating all the rows as if they're the same. You also can't have residual covariances built into this as well. So it is going to be just a diagonal R matrix. There's no other alternative for that. Okay, question?
Yes. First, how can we test relative fit comparison here? Relative model fit.
AIC, BIC,
But
likelihood ratio tests.
Okay, yes. And can we test absolute model fit if we are under the same framework?
In this framework, in very limited cases, you can. You cannot do it if you have any random slopes. Only random intercepts. The problem is once you end up with a model predicted V matrix that would vary by person, there's no more absolute fit that's possible. There's no single answer key H1 model. So you leave the world of absolute fit if you have unbalanced time or if you have random slopes. Yeah, it's not a thing. In multi-level SEM, you will not see like CFI, RMSEA, any of that stuff. It's not a thing. Very few cases would it even be possible to compute in the conventional way. how about a predictor? So I took my quadratic model and I added a level 2 time invariant predictor to each of my random effects, which I've called level 2x. So my picture now has a box sitting on the top right-hand corner. This is also a single column, but it would be a column in which the rows for the same person have the same value, just like in regular stack data. This level 2x is purely a predictor. It is not part of the likelihood. That means that if I had any missing values, I don't get to keep those rows. So far, it's the same. So in the level 2 equations is where I would pick up the fixed effects. So gamma O1 is the effect of level 2x on the intercept. That's the middle path right here, gamma O1. Gamma 11 is the effect of level 2x on the linear time slope. Here it is over here. And last but not least, gamma 21 is the effect of level 2x on the quadratic slope, which takes us to over here. And I have the same typo of U2 needing to be right here. I got it right in the composite model, interestingly, though. Hang on. I'm going to fix this because it's going to bug me. You can tell, like, the picture, like, got ported across the pictures and then changed or not by the pattern of typos. There. Fixed. By the way, this was a very good piece of advice that faculty once gave us in grad schools. Fix your typos immediately. Don't say you're going to do it later, because you will forget. And 2 years from now, I'm going to have this same error, because I will have forgotten that I ever made it. So we're fixing these immediately. Unconditional, conditional, that's where we were. Okay, slide 10. So the model looks the same except for the addition of these 3 new fixed effects. Here's the code. Spot the difference in the code. Have a question. Would M+ get rid of the rows with missing data automatically, or does this need to be specified before running the model? It will do it automatically. When you get your output, it'll tell me how many rows of data it read and how many it kept. What's new in the code?
The last row.
The last line. So in the level 2 model, between, because that's level 2x, the same way that level 2x shows up in the level 2 equations, I have level 2x as the predictor because it's on the right side of the on, predicting 3 different outcomes, is the way you would think about this. Each circle is an outcome in this model. Beta 0 is an outcome, beta 1, and beta 2. If you forget the direction of the on, think of it as an equal sign. Anytime we write an equation, it's y equals predictors. Just put an equals there in your mind, and then you won't get the direction confused. Because I don't talk like that. I never say the regression of y on x. I always say x predicts y. And so, like, from that perspective of x predicts y, you'd think it would be like x, something y. That's not what it is. So think of it as an equal sign. So this is the level of complexity that we got up to in example 2, a time invariant predictor, and up to a quadratic model potentially. We had a level 2 squared box over here to add into the story, but otherwise this was about as much as we've seen. So do you want to see something new? Okay, watch carefully. Ready? Okay, what changed?
The direction.
Yeah, red arrows. So if you wanted to say, for instance, does growth during elementary school predict some high school outcome? That story problem. Arrows go the other way. It's that simple. Once you've gotten to this level of hard, right? Like from there, turning the arrows around is pretty straightforward.
Lisa,
Yes.
if we are estimating the factor means and variances, what is the meaning of those factor loadings now?
We don't have any factor loadings in the story.
So those red arrows, they are not factor loadings.
They are not factor
Just
loadings.
regression.
They are regression
coefficients.
slopes.
Regression slope. And what is the interpretation of those regression slopes?
So here's the situation. My notation scheme falls apart when you start to introduce other outcomes, because all of my terms up to this point, the gammas and the u's, do not say what is being predicted. It's assumed that they're predicting y because that was the only possibility. Now I have a prediction of a y at the same time that I have a prediction of a level 2x. So my notation scheme for y would have to pick up either a y subscript on everything, or sometimes people do a superscript to say what outcome is being predicted, although that gets tricky because then it looks like squared sometimes and it's not. So there's no one universal way to notate things, just I wanted to put this out there. This is sloppy because this is sticking x's on here to differentiate them would mean I'm sticking y's on here, but I'm trying to keep this consistent with what we're used to. So what I've introduced is a separate simultaneous linear model for level 2x as an outcome, in which it has an estimated intercept and it has 3 slopes that are describing how beta 0, beta 1, and beta 2 would each uniquely predict this level 2x. And then it would have some kind of residual variance thing left over, which I used u for since it's a level 2 term. So level 2x would not have a random intercept and residual because it's only at level 2. It would only have e variance at level 2, whatever letter you want to use for that. I'm sticking with u to be consistent.
Lisa?
Yeah.
So in the result section for the between part, we will have different coefficients for y. For example, in this case, because at level 2 we have the factor mean, but also we have the regression slope for y on your level 2 predictor. Those are differentiating the outcome.
Say that again.
For the between part, we will have different value for y. We will have, for example, the factor mean variance in y, but we also will have the regression slope for y on your level 2 predictor.
Yes.
Those things are differentiated in
Yes.
that section.
So like in the previous picture, when level 2x was a predictor and y was an outcome, these would be variances left over, which is why I changed it to RV for residual variance and I for intercept. Because from the perspective of a linear model, these terms are now whatever's left after level 2x is predicting it. So the results will be different if you stick level 2x in as an outcome. You flip the arrows because it is a different model.
Okay.
Is that what you're asking?
Yeah, but also because in the between part, we will have 2 different values for that y.
Two
there.
different values.
Yes, because first we will have the factor mean.
Yes,
related to
that's
value.
in
Yes,
here.
Exactly, the
Fixed
first term.
intercept. Mhm.
But then we will also have a regression slope for that y. Because
Yes.
that will be the regression slope of y on your level 2 predictor.
Yes, so the y right here in the second to last line is
Yes.
beta 0.
Okay, and those will be in different places. That's my question.
Yes,
Okay.
yes. So the fixed intercept for the model is the mean of the y latent variable, the intercept. So I wish that I could change y into int because that's what it is, but I can't.
Okay.
Of course not. Right? So yes, this y in brackets is the fixed intercept, which is the average intercept for y. The y on level 2x is a slope for how level 2x changes for a 1 unit change in the intercept.
And you are using lowercase for y, but then after width in the
Oh.
third line, you're using the capital.
Yeah, that's an accident.
Oh, okay.
M plus doesn't care.
Okay, good.
The way that I write code is that anything, let me put it this way. The way that I write code in packages that aren't case sensitive, like Stata makes me put everything in lowercase, which is why I constantly refer to Stata in uppercase just to fuck with them, is, I do. It makes me mad that I can't do that.
struggle when I'm doing homework in Stata.
I know. So anything that is a dedicated program command, I put in capital letters. And anything that is like a variable or something I would switch, I probably do either title case or some lower combination. So
Okay,
I think I just typed Y pop capital here by accident. But you know what I'm going to do? I'm going to fix it. Where did it go? Here. This slide. We're going to fix this too from before. And we're going to put this in lowercase. But everything is in uppercase in the output. M+ doesn't care. But to make it consistent. Thank you. Yeah, like level 2x is sort of a title case thing because I made it work that way. Okay. So then this option of having a level 2 predictor as an outcome instead foreshadows how we could have missing data on it. What if we said, can you just give me the mean of this variable and the variance, but don't make it be predicted by anything? Just like kind of let it float out there by itself. That would be like taking out the middle 3 terms and just leaving an intercept and a residual. So if in the code you refer to the last line here, level 2x in brackets means give it a mean, level 2x outside the brackets means give it a variance, and you don't have anything predicting it, then it is in the likelihood as an outcome, which means you can have missing data under the assumption of missing at random. It then means it's assumed to be a univariate normal variable, though. So I'll say that again. The way that you can allow missing data on a predictor is to pretend it's an outcome by asking the program to estimate its mean, variance, or covariance with other stuff. But you can't have everything at the same time. If you're willing to say that it's an outcome, that means you're making distributional assumptions. And it's missing data under an assumption of missing at random, meaning it's random only after conditioning on the rest of the information in the model. There is a reason it's missing, but all the reasons are somewhere in the story that I have. So you can turn it into an outcome in the sense of having it be predicted, or you can just pretend like it is and just ask for basically an empty model is what it would be for level 2x. If you didn't have anything predicting it, you're asking it for an intercept and a variance. And I think, yep, that's a good segue point. Okay, do you want to see some code? Some more code, I should say. This is generic code. But I promised I had example 2, part B, or part 2, the SEM version. So this is the age cohort stuff. I took out all the bad models. Just time, okay? No more age, no more time. Time wins. Do you know why? Because you can't screw it up. There's no assumptions of convergence or composite trajectories that you need to make. Time is just whatever happened since you got in the door. So I took out all the age models, and this is what's left. So we are predicting an outcome of memory performance, recall on a test. We have an empty model. I've got the stata code and the R code and enough output for us to be able to map the results onto each other. So this is just an empty 2-level model at this point, meaning I've got a fixed intercept, I've got a random intercept variance, I've got a residual variance, 3 parameters. So -2 log likelihood is what I'm used to asking for because that's what we use as an ingredient to do likelihood ratio tests. Log likelihood is also what is shown. It's on stata by default, it's on R by default, and it's the only thing that M+ will give you. M+ will not give you -2 log likelihood. So here are the 3 parameters: a variance of the intercept, a variance of the residual, and a fixed intercept. And we create an intraclass correlation for the proportion of total variance that's due to level 2 random as 0.67. Okay? Here's M+. So there are only a few different sections of the code that you would write. And by the way, inside the download packet, so this is the packet that I put on the internet as a zip file folder. These are all the original files. Input files have .inp and output files have .out, but they're just text. So you can open them in Notepad or WordPad. You can edit these files if you want to. Make notes to yourself. One other thing that I didn't mention is that the input to M+ is a CSV file without names at the top. So you have to tell it what your variable names are called because they're not in the data. Very common mistake to forget that, and it will say something like, the first observation is a non-recognized value, or like something really unhelpful. That means it said words, eject. If it sees words, it just says no. So I have additional annotations and things in here, but otherwise the code is just straight from those packages and colored up so that it looks a little bit easier. So title is a piece that you can use or not use. It shows up on your output. Data, where was your data file? If it's in the same folder as your input file, which is what I highly recommend, you can just type file equals and then the name and the extension. Otherwise, you have to deal with the path. When you're using M+ on the virtual desktop, try to store your files as close to the root directory as humanly possible. We've run into issues in the SEM class with this repeatedly. I would encourage you to use the H drive and with as few folders as possible if you're working on M+. I have these two options that are default, but just in case you ever need to change them, type equals individual means individual level data as opposed to, say, a matrix input. And then free format data is what CSV or like tab delimited would be. Fixed format is much trickier to work with, but you can have it. Then we get to the variable section. Names is every name, every column that is in your data set in the order in which it is there. Each of these names can only be 8 characters. Otherwise, it will give you error messages and only print the first 8 characters. So you can have a 17-character name, but it just won't print the end of it, and the end of it is usually where the differentiation happens. So I would stick with the 8. So I've got person ID. I have like an integer for which occasion it is, like 1, 2, 3, 4 kind of thing. Age at time 0, time varying age, because that was in the data set before. I'm not going to use it. Tag. I don't want it to be tag. Thank you. Recall and time. All of the variables that are to be included in the current analysis go under use variable. That way you can tell it which ones are involved right now. Recall is the only one that's involved right now. Missing data code. I am somewhat superstitious, but I've had bad luck letting it figure out what blank means as opposed to decimal point. So I fill in missing data manually before I bring my data into M+. You don't have to, but again, I've seen it go badly. So -999 is all missing data in all the columns here. Then the last 3 you may not have seen before if you've been in the SEM class because we didn't use them. These options are specific to multi-level SEM. Cluster is, what is your level 2 ID variable? Person ID is what I call it, as usual. Between equals and within equals are empty right now, but those are going to be predictors that are only at one level or another. Not ones that we're asking for it to partition the variance, but just ones that are at a level or the other. Analysis type, 2-level and random so that we can eventually have random slopes. Estimator equals ML, and I'm doing that so that the results match those of Elmer, SAS, Stata, etc. I have a note here that level 1 is within and level 2 is between, so anything in green is a comment. Model then tells us what we're going to be estimating. So recall by itself in the within model is referring to its level 1 residual variance. That would normally be an R. Recall as the outcome in brackets is referring to its fixed intercept, and then by itself is its intercept variance. Number of free parameters, it tells you this is the output now that I've truncated down to just what we need. Free means free to not be 0. Like free to be me, free to be you, free to be 3. So that's the number of estimated parameters. And then the HO value, that is your log likelihood. Sometimes this will have an H1 as an alternative and sometimes not based on what's in your model. But this log likelihood is negative 1428, which is exactly what it is in R. It is the same thing. I've seen like the decimal places get off a little bit, like this is 628. Let me see if this is, okay, this is 628 to the rounding as well. So tiny differences, if any. And then here are the results. So estimate standard error. Estimate divided by standard error is treated as a z, not a t. And then the last column is the two-tailed p-value. So there's no degrees of freedom. That means everything's going to be a z or a chi-square. Within level, variances. What is 5? What's that telling us?
That's the fixed intercept, right?
Nope. It's under within and it's under variances. So it's got to be something in the model for the variance.
You see that written?
Yeah, this is level 1 residual. So this is the 5, is that number right there. Off a tiny bit in rounding. Between level, means and variances. So they're labeled this way because nothing's predicting it yet. So another way of saying it is that 9.7, which we would have called fixed intercept, is the mean of the latent intercept factor. It is the mean of the beta 0 latent intercept factor. So 10.4, the last entry here, it must be what? What's left?
Random intercept variance.
Yeah, the variance of the latent intercept factor, the variance of beta 0, otherwise known as U0 variance. So it still separates out fixed and random effects, but they're just like labeled the same, with attached to the same variable, where recall means intercept. But this sets up the idea of multivariate, though. Like, could I predict, in addition to a memory outcome, could I predict, say, a processing speed outcome in the same model? Sure, I could. And then I would have an entry for speed underneath this, which would be the fixed intercept for the speed outcome. And I would have a variance entry for speed, which would be the U0 variance for speed instead. Okay, we're skipping the SEM version. We'll come back to it. Jumping up in complexity just a scotch, fixed quadratic time random intercept. So the syntax in Stata would look like this. So no random slopes yet, just time and time squared as new fixed effects at level 1. Likewise, in R, the parenthesis section that defines your random model has only a 1 in it, and then we have the fixed effects here in the column. Here's what R gave us for comparison. Here's our M+ code. The only changes are to the variable section, there's a couple. These two variables get added to use variable, time and time squared. So we're introducing those as additional columns to be used in the analysis. Note that time squared doesn't exist yet. I don't have it on my list of variables. I got to make it. Likewise, because these are both purely within level, I'm putting them on the within statement under the MSIM options. And here, under define, is where I'm making it. So define has a bunch of choices for variable transformations, but some of them have some weird order of operations problems. I would not try to do anything more complicated than center stuff or square stuff with define. I would not. I would do it in your home program and import it directly. So I'm making time SQ for time squared. So then that goes at the end of use variables. Anything that's newly defined has to go at the end, and it goes on within next to time here. So given that I only want fixed effects of time and time squared, I can do that directly in the level 1 model. So I have recall on time squared, and the level 2 model is exactly the same as it was before. I've only added fixed slopes at level 1. So because I wrote it so that the fixed slopes are only in the level 1 model, they show up in the within, and here they are. So time, or recall on time, 0.26, what's that thing?
Regression slope for time.
That's the linear one. And this one must be then? That's the quadratic. And that's why I got the numbers, so you can look back and check your intuitions here. And then, now the label has changed. Residual variance. So this is the residual of the residual, meaning the leftover part of the level 1e after controlling for time and time squared. At the between level, the labels are the same. The interpretation of the mean is different though, because this is, it doesn't label it that way, but this is the fixed intercept. It's unconditional from the perspective of nothing in the level 2 model predicting it though, which is why it's being called a mean. And random intercept variance is the last term here. Okay. So it's not so bad so far? It's confusing though. Like, I feel like you need to know what you're doing first before you try this, because there's a lot of room for ambiguity in what the stuff means, the way that it's labeled. And the user's guide is not helpful in that. The user's guide is designed to help you write the syntax. It is completely agnostic as to what any of the results mean. So, which is a good thing, because otherwise I wouldn't have a job. Other people's ambiguity is my job security. And yours. And yours. Remember, what can you now add to your CV under technical skills section at the end of this unit? You can do multi-level structural equation modeling. Just don't tell anybody that it's the exact same thing as you did in Elmer or whatever, right? It sounds cooler this way. All right, 142. I think that's good enough for today, maybe, yes? And we'll look at the other models next time and then transition to SEM, which is about what I expected. So no new material until next week at the earliest. This'll take all of Thursday and maybe another day. But I'd rather do it well and thoroughly than like rush through everything and not do a good job on it. So we may have to dump a couple topics, but I can give you resources for anything that we dump. Questions before we adjourn? Yes?
Could you say more, again, just re-explain why exactly when we have fixed effects only for time and time squared, for example, they show up in just within, because if we add a random effect for time and time squared, we're going to have both, right? It's going to be within and between for the output, right?
If we were to add a random, these lines would move to the between model.
Well, they would completely move.
They would completely move.
Okay.
So the question was, why is it that the fixed slopes for time and time squared are in the within model? And it's because that's where I put them. The difference between this and the alternative, let me just show you like one of these. Let's go back to something that looks like that. This is unconditional quadratic. So the placeholder notation here, I gave it a name and a bar, which means I'm creating a latent variable whose mean and variance are yet to be defined at level 2. Whereas if I just have this part by itself, I'm not allowed to have random anything. It's just a fixed slope at level 1. And you do get different results. Even if you were to say, like, put this at 0, which is what we're going to do to shut it off, it would be considered the mean slope of the person's slopes. Without the, like, if it's part of the level 2 model, it switches to that, whereas if it's in the level 1 model, it doesn't keep track of like whose data contribute. It's just one giant slope for everybody. So the short answer, good questions. This is fine if all you want to have is a fixed effect at level 1. But if you want to add a random effect to go with it, or you want to add, or you want to add cross-level interactions to create a systematically varying effect, then you have to have the placeholder and move everything into the between model. Okay, anything else? Yes?
Yeah, the computation of the ICC is the same.
Yes. Yep, ICC will show up on your output. I don't know if it's conditional or unconditional, though. It may give you both, but it will be on your output somewhere.
Okay.
Yep. All right, 1:45, so that means we're done. Thanks for being here, everybody, Roomers and Zoomers. Watch your email for me to tell you that we're not meeting on Thursday if there's a lot of snow. Otherwise, let me know if you need anything. I'll be working on your homework 1 accuracy drafts in the meantime, and have good days. Thank you. Bye, folks.